announcement is that we'll tentatively have class next week and then be off for 2 weeks while the lab is doing the Philly Flower Show.
Philly or Philly?
Both, accurate. Yes. All of the above.
Okay. All right, Joel, do you want to take it from here? I don't think we have any other announcements.
All right. Yep, so picking up from the last class, we got to couplet 13, which is where the species, you split off the species that have the scutum punctures dense throughout or sparse in part, and the in part means pretty much always the middle of the scutum is where they're going to be sparse. So I thought that we could go, most of the Dialictus, the most common state is to have the punctation sparse in the middle. There's a relatively small number of species where they're dense throughout. So I thought that we could go that way. So that goes to couplet 73. And there's few enough of those that we might be able to cover them all in one class. So these are fairly distinctive species, and as I mentioned in the last class, for this couplet, I'm going to go ahead and put a bee on the screen.
While you're, before we get too deep into things, but I think maybe this is where you're going, but it would be good to define dense in the world of Dialictus.
Yep, that's what I was going to do.
Okay.
So this is a perpunctatum, or close enough to perpunctatum. And this is what a densely punctate scutum looks like. So in previously, I mentioned how the kind of the key that you're looking for with this character is whether the punctures on the scutum are uniformly spaced throughout. So most Dialictus are going to have the punctures sparser in the middle than they are on the edges. So closer to the tegula, they're going to be really dense, and then towards the middle, they're going to get sparser. And that's true to some extent, even in these densely punctate ones. So like in this specimen, see if I can get this a little bit more in focus. You can see right in this area, it is a little bit sparser in the middle than it is at the very edge. There's some gaps in there that are about 1 puncture diameter wide, maybe very slightly more right here. But generally, they're all pretty uniform. They're all less than 1 puncture diameter apart. So you're looking for this general sort of uniformity from edge to edge of the scutum. And when you see that, then that's what it means, that it's dense throughout.
Joel, I see on this specimen, and I have another Eastern perpunctatum thing on deck if you want it, but is the scutellum useful here at all? Am I seeing a low density in the 2 sides of the center of the sides of the scutellum? Is that useful or not? I'm noticing it.
I don't know, to be honest, whether that's useful or not. I know I have.
Mm-hmm. I was gonna mention that the specimen I have of perpunctatum has that completely pitted on the scutellum. But you said you're not 100% sure what that is, but it's similar.
Oh yeah, so like my specimen, the scutellum is definitely more sparsely punctate in these submedian areas. So yours is totally dense throughout.
Mm-hmm. We can show it whenever you want. But I think
that might be that might be something worth looking at to see if maybe this is a different species after all.
Mm-hmm. I think.
But I have tried using the scutellum punctures for species level delimitation in some other species, and in those other cases, there's quite a bit of variation in the scutellum punctation, like more than there is in the scutum.
Mm-hmm. Yeah. I think what this illustrates is, one, people should be, looking at their specimens, particularly when they have long strings, to look for any departure from what seems to be patterns, and those departures can occur at different places on their specimens. So when you're morphosorting, which is always a good practice with the 50% of your specimens, which are going to be Lasioglossum, to do so you don't get overwhelmed. And sometimes that's useful, and sometimes it's not, as Joel has just mentioned.
Yeah, so I'd really want to look at like a nice long series of specimens to find out if this scutellum character is useful or not.
Mm-hmm.
All right, so that's what a densely punctate scutum looks like. So I think we can move on to couplet 73.
Do you want Claire to show the couplet, or do you want to talk through it?
Well, I will talk through it.
Okay.
You can also show it at the same time if you want.
So Claire, while he's talking, I think sometimes it's useful to have it up there because not everyone has that up on their screen. And plus it'll be recorded, and that's a good a good thing to have, because then people can stop the video and zoom in and look at what was written and go back.
All right.
Okay.
So couplet 73. This couplet will just pull out Perpunctatum, which is the only eastern species that we're going to be looking at today. The Pilosum group also comes out this way. Those ones have those dense punctures on the scutum, but we covered those in a previous class, so we're not going to cover them again today, unless we end up with like a bunch of extra time, but I don't think we will. So this is the only one that occurs in the east. The rest of them are all western. Actually, would have been good to put in the key. So Perpunctatum has a relatively short face. A lot of the other ones that come out this way have pretty long faces. I think if you remember the Pilosum group, when we were looking at those, that's the kind of faces that a lot of these other bees have. Or if they have shorter faces, then there's these other characters that will sort out those short-faced ones. So Sam, do you have some Perpunctatum?
Yeah. You want me to share that and we can take a look?
Yeah, maybe you can like show the face or
Okay.
the metapostnotum.
I can do both.
And then I'll show one of the other, whatever you're not showing, because there's multiple characters here.
Yeah. All right. I'm shifting to the specimen here to better show the face. And got it in my sights.
At the sternum.
All right, there we go. Let me just angle it. I just want to make sure that we can see that it's very short. So I want to get it at a 90. This is an important point in general, that when you're looking at short and long, you need to have the plane of the face at right angles to your microscope, or in this case, the picture. All right, I'm going to share, and then you'll see our eastern but dirty Perpunctatum. And there we go. Visible there, Joel?
Let's see. Hold on. Yeah.
Okay. I'll mention something. It's not very visible here. In addition to, talking about the head shape, is that a lot of times on these perpunctatums, the supraclipial area doesn't show well here, is a little bit raised and a little bit purple in these eastern ones. But go ahead, Joel, take it away.
Yeah, so this is a pretty short face. So if you measure the distance from the edge of the compound eye to the edge of the other compound eye, so like the widest point to the other widest point.
Go ahead.
Yeah, so you were kind of moving your mouse like at the bottom edge of the compound eyes, but what you want to look at is like the furthest edge to the furthest edge of the head.
I mean, sort of up here? Is that
the spot that's kind of covered up by the antenna. So the widest part of the compound eye where it curves out from the head at its furthest point. It's like the maximum width of the head is what you're looking at for the width. And then for the length.
Joel, can I interrupt? Yeah. Maybe I was doing it. Are you talking about the inner edge or the outer edge of the eye?
The outer edge.
Okay, so you're right, directly behind the antennal edges. So the outer edges there. Yeah. Okay.
Yeah, and then you look at the length from the bottom of the ocellus, the median ocellus, to the edge of the clypeus. And in perpunctatum, that's going to be it's going to be wider than long, slightly, or possibly about as wide. So
Got it.
You can just kind of eyeball it here, and you can see like, oh yeah, that looks maybe a little bit broader than long, not a lot, a little bit.
Yeah. Well, when you have a long series, as you often do, of the pilosum group, then the contrast is pretty easy to see. It's less when you have just one specimen. That's, again, points out why doing morpho sorting is helpful, and looking at lots of things is ultimately your friend.
Yep. So there's a bunch of long-faced species that also have these dense sputum punctures. And those ones, the head is going to be much, much, much longer than this. It's like super obvious, no question that it's longer. But there's some short-faced ones that also need to be distinguished from perpunctatum. That's what all these other characters in this couplet are for. So it's like the face is long unless this and this and this. So I can show some of those. And Sam, if you want to twist your specimen so you can see the mesopisternum, because mine that I'm not 100% sure is really a real perpunctatum. The mesopisternum doesn't match what it says in the couplet.
Okay.
So not the best example. But the metapostnotum, which is what I'm going to show next, does look right. So I can show that.
All right. So here, am I still on deck, or are you? Okay. So this area right here, I can go in even deeper. All right, Joel, go ahead.
So this is the metapostnotum. So perpunctatum and actually most of the other species in this group, it's the Perdiphycile group is what perpunctatum is in. They all are going to have this metapostnotum, or this propodial triangle is what it's also known as. This dorsal surface of the propodium. It's going to be completely rugose. all the way to the posterior edge. So filled with these kind of like irregular ridges, and they're going to go all the way to the edge. There's not going to be, in other species, there's going to be sort of a smooth, rounded slope at the posterior edge. So there's going to be sort of like a curb at the back of the propodial triangle that'll be distinctly smooth and shiny. It's going to look different from this coarsely rugose basal area. And actually, I can go ahead and I'm going to grab an Ebmerellum, which is one of the species that has the alternative state.
I'll also point out while you're doing that, another difference, again, color, a little tricky, but often the patterns over many specimens kind of come clean. As Joel's specimen, interestingly, was very blue. At least in my book, it was very blue. And this one is much more of a brassy green color, which is what I normally associate perpunctatum with.
Yep. So while I'm getting this ready, Sam, if you can show the mesopisternum on your perpunctatum, so the side of the thorax, because that's another character that's used in this couplet.
See if I can get it to show without anything blocking it.
All right. So I'm going to go ahead and share my screen. Oh, okay. You got the mesopisternum. Well, let's look at this now.
So this area here.
Yep. So in perpunctatum, that area, so you're looking, the mesopisternum is the side of the thorax, and the side of the thorax is kind of divided into three segments. Like the top of the thorax, you have like the pronotum and the mesonotum and the metanotum. Side, you have also those three segments. So the mesopisternum is the middle one. So it'll be right below the tegula is what you're looking at. And it's a little bit covered up by a leg actually on here, but you can still see some of the punctures there. And what you're looking for is this distinctly punctate, not super shiny, but not super dull. So it's, I believe what it says in the key is faintly polished. So not like mirror smooth shiny, but it's not going to be dull, and it's going to have distinct punctures. And that's what you're looking for in perpunctatum. There's some other species where this area is going to be impunctate. It'll be more rugulose, so without any distinct punctures, and it'll be much duller than this. So that's what you're contrasting with. Yeah, so you can see like down where that blurry leg is at the bottom of the screen. So right next to that, there's those interspaces between the punctures, and there's some faint tessellation there. So there's microsculpture, but it's still kind of shiny.
again, very useful to look at lots of specimens.
And okay, so if I can switch back to
Mhm.
Emerald now and show
Okay.
that alternative Propodium. So yeah, sorry, we're kind of jumping around a bit here. So that was the Mesoposternum. I'm going to jump back to the Propodium. So this is the propodial triangle on Edmerellum, which is related to Perpunctatum. It's in the same species group, but it's the only member of that group that lacks that totally rugose propodium. So on here you can see those rugae, they're definitely there in the basal half of the propodium, has that definite ridged rugose sculpture. But then towards the posterior margin, it's smooth. So like here where it kind of slopes down onto the lateral edge, it's not shiny, but it's definitely smooth and rounded. It looks quite a bit different from this basal area. There's no ridges there, just some tessellation.
Joel, I'm seeing on there, particularly when you magnify it, two areas to either side of the central line that are sort of like, I'm going to say, it looks like they're pulled up, kind of looks like little eyes and dark. What's going on there? That doesn't look like
These
other
dark
species.
spots,
Yeah.
I'm pretty sure that's just lighting. It's just
Okay.
shadows, like reflections.
hmm
So I'm going to try rotating the specimen a bit. And yeah, they're still there. So I think it's just light though. But the important thing here is just that this is very smooth compared to the basal area of the propodium. So if you see that, then it's not a perpunctatum. And actually,
There are pictures in your 20, there's the refurb, 2020 or 2010 key that,
You're reverberating there.
yeah, I think you have something going on. Do you have a, just look at the 2010 key for more pictures.
yep. Also, Edmerellum has a pretty long face, so it'll also rule out perpunctatum that way. All right, so then Mesoposternum, Metapostnotum, we looked at those. And then, yeah, if the metazomal turga are metallic green, perpunctatum can be a little bit metallic, so that can be a tricky one. So don't just look at the color and base it purely on that. But it's a pretty weakly metallic green. If you see one that's like really obviously strongly metallic green, it's not a perpunctatum. Then it will also have that propodium, not so completely rugose. So
And and T2 is not as heavily pitted, particularly towards the rim, as our friends Leucocomus and Pilosum.
right, yep. Persinogaster, though, can be similarly pitted. So
Okay.
there's some Western ones that can look similar. All right, so then I think we can move on to couplet 74. Moving on from perpunctatum. Anyone have any questions about perpunctatum? I know that's kind of a tricky one that people mistake a lot.
Yeah.
Yeah,
Claire,
so
you want to put up the guide?
Come back to them.
I was going to ask Claire if she could put the guide up so we can, while you're talking, look at the how you wrote it.
Oh, yep. So there's the guide. There's some nice long faces. All right, so are you moving on to 74 or? All right, so this one's pretty simple. Just is it metallic green or not? The metazomal turga. So there's not much. There's not much variation here. Perfunctatum is really the only one that's kind of in between. So that's why it's pulled out first. The rest of the species, they're either going to be obviously non-metallic, black or brown, or they're going to be clearly green or blue on the metazoma. So pretty simple. Probably don't need to spend very much time on this. So we can do the black ones first, moving on to couplet 75. And that starts with T1. And whether or not there is tomentum at the lateral edge of T1. And this is a pretty useful character for a lot of the species in this group. And also a pretty useful character just for general morpho sorting for Western species. The one problem is that if you get worn specimens, the tomentum on T1 can get rubbed off a lot, and there'll sometimes only be a few CD left. But if you get a worn specimen, there's usually going to be a little bit left, so just look for those oppressed, densely plumose CD is the tomentum that you're looking for. So I'm going to put Ebmerellum back on the screen.
And usually that tomentum is bright white.
Yes.
Is that the case here?
Yes. And actually, the pilosum group also has that tomentum on T1. They don't key out this way because they're metallic green. But if you're looking for another example, those do have that T1 tomentum as well. And it's going to be yellow in those ones. All right, so I'm going to share again. So this is Lasioglossum ebmerellum. And here's the metazoma. You can see T1 first segment here. And here's T2. And here's that oppressed tomentum on T2. So most Dialictus, they're going to have some oppressed tomentum in this kind of like basolateral corner here. But a lot of Dialictus, most of them in fact, especially in the east, T1 is not going to have any of that. But in these species, what you're looking for on this very lateral edge here, there's going to be some of that oppressed tomentum right in this area. So there's not a lot, just kind of a thin line. Yeah.
Can I guide you through making your cursor larger? It's super teeny on our screens. So you're on a Microsoft, right? So if you do the Windows and then S, and then type in the word cursor, and you should find something that says cursor size, and then you can slide it so your arrow will be big, and that will be helpful.
Windows S. Oh, that didn't open the start menu.
You know, the little Windows key button.
And then cursor.
Mm-hmm. And then it should, you know, it could be, it might say mouse size or cursor size, something along those lines. And then there's a slider, and you want to put it basically in the middle, like 7. And then just flip back to the screen.
Oh, yeah. Okay. That's a giant cursor. That better?
I'm Is it bigger on yours? I'm not seeing it.
It's bigger on my screen.
Okay. It should show
Maybe
up.
if I try resharing, I'll stop and do it again.
Okay. Because when you're pointing out these fine details, that's really handy. I think the cursor
How about
as
now?
is small.
Is it big now for you?
No, for some reason. It should be big. It's like super deep. All right, let's not worry about it, but maybe another time we can try and get that to be big. I mean, I can do it on mine, so we'll figure it out.
Yeah, it's big for me, so I don't know why it's not
Huh,
showing up for
odd,
you.
yeah. Okay. All right, so sorry for the distraction, but we will look for the teeny arrow now.
Yeah. Yeah. Hopefully it's not, as long as it's moving around, you should be able to see it.
Mm-hmm.
Just look for the movement. So yeah, right. Yeah, this lateral edge here, just look for this little thin band of really plumose. See if I can actually zoom in more. So you can like really see the individual seedy. Yeah, here we go. Yeah, so like look at right here, those seedy. See how they're like really fuzzy? They have a lot of branches coming off the side. They're super like feathers. And then contrast that with like these ones just toward the middle of the segment. They're simple, thin, not fuzzy at all. So when you're looking for that oppressed tomentum, you're looking for like fuzzy feather-like seedy at the lateral edge of T1 there. Yep, right there.
And these tomentum patterns are really good characters in a very general way for morpho sorting, and they come up over and over again in terms of the density and the patterns and how much is there. Sometimes there's almost nothing, sometimes really nothing. And other times you might get nearly the entire segment, whatever you're looking at, whichever of those tergites you're looking at, almost completely occluded. In Discover Life, we often use that as rough percentages and overscore so that you can use that as another way to get into the answers.
All right. So I think we can move on to 76. So if T1 doesn't have any tomentum on that lateral edge, like I showed you, there are two species in this area of the key that don't have any tomentum there. And these are both Western. Actually, all the rest of the species we're looking at now are Western. And these are fairly common. And so Macroprosopum and Bruniaventer, these are closely related species. They're in what's called the Bruniaventer species group. And they look pretty different if you see a specimen of each side by side. But if you actually try to like quantify the difference and explain it, it's not easy to do. So Macroprosopum is bigger than Bruniaventer, but as I've mentioned before, size is not 100% reliable character. So small Dialictus are always going to be small, but big species can sometimes be small just because of morphological variation, or there's casts in the social species. So it's not always 100% reliable just to look at size. So the other way to tell apart Macroprosopum and Bronyaventer is by looking at the face. So these are both pretty long-faced species, but Bronyaventer is a little bit longer, and it also has a little bit different shape. If I can get a specimen on the screen here.
While you're doing that, and maybe you can show this too, you use the term ocular tangent, which is unfamiliar to me.
Yeah, so the ocular tangent. So if you remember back to your elementary school or maybe high school geometry classes, and a tangent line is if you have a circle and you kind of like draw a straight line coming off the curve of that circle. So you can do the same thing following the edge of the compound eyes on a bee. So if you just like follow the curve and then you stop following the curve and just draw a straight line, that's what I mean by a tangent. So when I say the upper orbital tangent, that will be a straight line drawn across the tops of the compound eyes.
Great diagrams is the key.
And okay. You get the specimen squared up so the head is straight on, because that's important to do when you're looking at these head characters, as Sam has mentioned. All right, that looks pretty square, so I think I can go ahead and share again. All right, so here is Lasioglossum Bronyaventer. So this is the smaller one with a little bit of a longer face. And the key is that it's also a little bit shaped differently. It's going to be more of an oval face. And what I use in the key is if you look at this upper orbital tangent, so draw a straight line across from the tops of the compound eyes like this. So you follow my mouse, that line right there. The middle ocellus is going to be more or less above that line. So it's a little bit overlapping that line on this bee, but the middle of the ocellus is above that upper orbital tangent line. So it has this strongly convex, kind of tall forehead. So Bronyaventer, yeah, you can think of it as Bronyaventer having a tall forehead is what you're looking for. And all the ocelli are going to be well above the compound eyes. And that'll be contrasted with Macroprosopum. And I'm going to grab one of those. And I'll do my best to get it squared up neatly.
Are these throughout the Rockies and West, or do they have restricted ranges, or how would you describe it?
They're not in the Rockies, so they're
Okay.
further west than that. So these are kind of Pacific Coast bees.
Mm-hmm.
So they're in the Northwest, California, and they get as far east as like western Montana. Utah is probably the furthest east that you're going to find these. So pretty far west bees.
Hmm.
Would be worth noting, these are not, I'm posting the links to Discover Life species pages, but they're not key to Lasioglossum regular key.
We're waiting for those Western heroes to expand the guides to the West. David Capper,
Yeah.
we're looking at you.
All right, so here is a macroscope face. So it's definitely it's shorter than Bruniaventer, but it's kind of hard to quantify. But the important thing here is you look at this upper orbital tangent, draw that line again across the tops of the eyes, and the middle ocellus is going to be like smack on the middle of that line. So not so tall of a forehead. The ocelli are not so raised above the compound eyes.
Hmm.
And that is a pretty good character for telling apart these two species.
Have you tried using that character on other specimens? Are most of them above or below, or what's the pattern? You know, if you pushed everything through and measured them, or you don't know?
Do you mean for other species besides
Yeah.
Macroscopium and Bruniaventer? Most Dialictus are going to be more like Macroscopium, so the ocelli are going to be lower down like this. Bruniaventer is the oddball for having them high up. And worth noting, there's a lot of undescribed species in the Bruniaventer group, especially when you get down in California. There's probably at least 2 or 3 of them that are undescribed. And
So when you're using that key and you key out to Bruniaventer, would you put that name on it, or would you say Bruniaventri group?
yeah, I'd say Bruniaventer group. All right, so yep, that's hopefully clear now. And I think we can move on. So jumping back to couplet 75, back to that T1 tomentum. So those are the ones without tomentum on T1. Now, if you have one with that lateral tomentum on T1, you go to 77. And at this point in the key, this is all Pertifacile group. So the Pertifacile group, it's Perpunctatum, Admiralum, Yukoni, Onifurqui, Sheffieldi, and there's also a lot of undescribed species in this group, in the southwestern U.S. and also in the northwest. There's some undescribed species. So south of Canada, be careful in this group.
What was the species group called again?
Pertifacile, which is funny. It's Lasioglossum pertifacile is the oldest named species in this group. That's why it's the Pertifacile group. And it's funny, the Latin name actually literally means very difficult. So it's the very difficult Lasioglossum.
Like the nightmare one?
Yep.
Taxonomics humor.
Yep. So cockerel was, I think, yeah, Jason was not the only one to recognize that these were very difficult bees. Cockerel noticed that long before. Yep. So couplet 77. So actually, we already looked at this. So this is the metapostnotum. This is pulling out Admiralum. So looking at the metapostnotum, is it totally covered by those rugae, those ridges, that rugose sculpture? Or is it about 2/3 covered with that smooth, rounded rim at the posterior margin? So if you remember when I showed the Admiralum on screen, that's what you're looking at here to pull out Lasioglossum admirallum. So we shouldn't need to look at that again. So we can move on to couplet 78. So this,
These ones are all Western as well?
yes, these are all
From the
Western.
primer.
So couplet 78, these are the ones in the Perdiphycile group, and should be noted this is for Canada. So it doesn't include the actual Perdiphycile because that's a New Mexico bee. So these are the ones in Canada that have that T1 tomatum, and they have the completely rugose propodial triangle. So there's Onufurcoi and Yukoni. So Onufurcoi, you're probably not going to get. It has a very, very restricted distribution. It's only in this small area of sand dunes in western Saskatchewan and eastern Alberta. So if you're not in sand dunes and you're not in Alberta or Saskatchewan, you're not going to find Onufurcoi. And I actually don't have any specimens of that one here. Even though I did describe that species, all the specimens are in Canada. So I can't show you that one, but I can show you a Yukoni.
So just to dwell a second, so those wings would be very similar to like albapenni and maybe a very few other species where the wings just look really white. And the reason for that is vein color and the hairs, the tiny, minute hairs on wings, which is odd, right? Wire hairs on wings. That you don't see, but color the wing.
Yep. Yep. So Onufurcoi has those pale wings with pale veins and pale hairs again, like albapenni, pruinotum. Those are common eastern species that have that. So Onufurcoi also has those pale wings, which is a very good character to separate it. The other one that's useful and actually a very good way to recognize Yukoni is the Mesopisternum. It's going to be impunctate, so no distinct punctures, and it'll be really dull, so really imbicrate or tessellate. And I'm going to share screen.
So imbricate would be fish scale like, if I remember. So the little tiny microscopic lines would look like little fish scales, and maybe we could see that.
Yeah, so imbricate and tessellate are kind of similar. So when I say tessellate, it's usually more square, so like more like a chessboard pattern, and imbricate is going to be more irregular. Yeah, more like fish scales. It's a good way to describe it. But they're pretty similar otherwise. So this is actually, again, I'm not 100% sure that this is a Yukoni, but it looks similar enough to make no difference for learning purposes. So this is the Mesopisternum, and you can see there's really not any distinct punctures here, and it's not completely smooth. There are some kind of vague pits, but not really distinctly what you would call distinctly punctate. And then you can also see that imbicrate sculpture in between the punctures. See if we can change the focus here. Yeah. So kind of a dull, slightly roughened, but not rugose sculpture. And that is within the Perdiphycile group. Yukoni is the only species that has the Mesopisternum like this. All the other ones are going to be much more distinctly punctate. unless this turns out to be an undescribed species. Like I said, I'm not 100% sure that it's a Yukoni, but it looks very similar.
Pointing out that if you're working in remote areas that haven't had a lot of bee people, you might think about sending Joel or Jason, depending on which country you're in, specimens of your Dialictus, because particularly out west, there's a good possibility that new things are there, and I know they appreciate the extra specimens.
Yep. And and then let's see, the last character in couplet 78, head long or head round. So we kind of already looked at that too. Yukoni, it has more of a perpunctatum head. It'll be on the shorter side, but it won't key up to perpunctatum because again, it will have that impunctate mesoposternum. And then Onifurcoi has a much longer head. Okay, so I think that covers 78. So then if we jump back to 74, so going back to Metasomos hirga, are they non-metallic black or brown, or are they metallic green? So if it's strong metallic green, it goes to 79. So how about 79? Okay, so again, we get to the mesoposternum. Is it punctate or is it rugulose? So shouldn't need to look at that again. Actually, the rugulose ones, the impunctate ones, going to 81, that's the pilosum group. So these are those eastern species, and we covered these in a previous class. The mesoposternum is going to be totally impunctate. It's going to be pretty roughened, rugulose. And they're going to have pretty long faces. So if you look at the mesoposternum and it's not like that, if it's distinctly punctate, often shinier, and if they're western, then you go to 80. And there's two species that come out this way, Persinogaster and Setae. And this is actually a very tricky species group with, again, a lot of undescribed species in California. So if you're in the Southwest, be careful. But in Canada, anyway, they're possible to identify. And we're getting a little bit short on time now, so I'm going to quick throw up a Setae.
While you're doing that, Dylan asks, on the vein of what Sam just asked about sending bees, is an option to hang out with us, to do a Zoom call with any of the people on there, Sam, Jason, Joel. Dylan now has a scope with the camera, and I'd love to get confirmation on tougher specimens.
That would be fun.
Sounds like there could be a compensation associated.
Yeah, maybe it's like a show and tell day at some point in the future where people can bring in specimens of anything, but Dialictus would be right up there. And if they had the ability to show it online, like Dylan does, or you can put a camera on your scope, lots of them can, and you can even slide them into oculars, then we can work on stuff. Good idea.
Yeah, that's kind of a clever idea. All right. So you got a Setae on screen now. It's also worth noting that this group, Prasinogaster and Setae, they're in what's called the Veganum group. And these are all kind of, they're not desert species. They're typically montane, so they like high elevations. They like temperate zones, lots of trees.
You need to share.
Yep.
There we go.
I'm working on it.
Okay.
Prasinogaster actually can occur in prairies and grasslands, but it also occurs in those montane zones. So this is a Setae, and this is the mesoscutum. And the mesoscutum is actually what I think the best way to tell Setae apart. So Setae has like one of the densest of densely punctate scutums. So it has very fine, very dense punctures. And what I use in the key is this area here between the parapsidal line. So right here, that line there, that's the parapsidal line. Between there and the edge of the scutum, if you look at the back edge of the parapsidal line and just go straight out to the edge of the scutum, there's about 4 to 5, usually 5 punctures jammed into that space. So they're so fine and dense that you can fit up to 5 punctures in this space here. And then the parapsidal line is also going to be really skinny and narrow. Contrast that with Prasinogaster, and I'll see if I can get one of those up.
So again, that's a cool character that I have not heard of before, and I'm wondering if scoring all the Dialictus, for example, because that's what we do in Discover Life, and counting the number of pits between the bottom of the parapsidal line and the edge would be very useful. Or is it just really another character?
I think it would be useful, yeah. It would just be, it would just be some effort to score all the species for that, because there's some where it's really variable. So you need to look at you can't just look at like a couple of specimens of each species and score it. You need to look at a large number to capture the variation.
Yeah, like one of the things about something like Discover Life is you don't have to do every single one, right? So if you did a bunch of them and there were a bunch that you didn't have access to sufficient string, you just leave them unscored and they remain no matter what you click.
All right. So that's not really straight down on the scutum. So but hopefully you can see here, since we're running short on time, hopefully you can see here that the scutum on this is a Prasinogaster. The scutum is shinier and more coarsely punctate. They're not so fine or so jammed together. And actually, it looks like about 4 punctures in that space between the parapsidal line and the edge of the scutum there.
Can you zoom in?
Yeah, I can zoom in. Yeah, so maybe this is not the best example. This is a difficult group because they are very morphologically variable. Occasionally, you get Prasinogaster specimens. I've seen a couple of them that look like a lot more Setae-like. It's possible that they hybridize. I think there might be some hybridization going on in this group. So this is maybe not the best example, but it is shinier and the punctures are more separated. They have more distinct interspaces between them, even if they're jammed together more closely. So hopefully you can see that here. like there's like 1, 2, 3, about 4 punctures in that space, and they're distinctly separated with shiny interspaces. And instead, they're going to be much more packed together. And let's see, other characters. The mesopisternum is also going to be shinier with the punctures more distinctly separated in Persinogaster. So scutum and mesopisternum, both shinier, more distinctly punctate. And the hairs on the Metazoma terga on Persinogaster are also, they're longer and shaggier kind of than in Setae. Setae has shorter, sparser hairs on the terga.
You're talking about the normal hairs, not the oppressed hairs, the prone white ones, right?
I'm talking about both, actually.
Okay.
So all the hairs on the Metazoma terga on Persinogaster are going to be longer and shaggier than they are in Setae. So it's actually kind of hard to quantify. Like in the key, I say there's extensive, usually dense tomentome with the hairs mostly touching one another. So that's how I tried to quantify it. But in general, it's just going to look longer and shaggier.
Uh-huh. Will it look denser? Is the
Yes.
effect also
Yes,
a
it also
greater
comes
density?
denser.
Mhm.
And then Setae, it's going to look less hairy. And then the T1, if you remember that lateral tomentome, there's also less of that in Setae. So this is, we're kind of out of time. So if we want to stay on, I can try to show more bees on the screen. Or we can. We've covered all of the species more or less, except for the microscope group, which we did in another class.
It might be good to show the tergal hair pattern, the general gestalt thing. And, you know, people can dial in and dial out as they wish. But I think if it's okay with Claire, we can just keep chatting here and it'll get into the video. We're good, Claire?
Yeah.
Okay.
All right, so here is the Metazoma. This is
a lot of good pictures.
This is still Persinogaster. So you can see that all this hair at the base of the terga, it's not really totally oppressed, and it's long enough that it can actually stick up a little bit. So they're kind of all long, and they're long enough they're all touching each other, and it's not super dense. But if you look at a Setae, it's going to be sparser than this. And then see if I can get that lateral edge of T1 visible. Now it's like the crumb or something covering it up. But you can kind of see right here on this lateral edge, there's these tomentose plumose hairs, and they go kind of like all the way up the edge of the tergum, and they kind of blend in with the acarinarial fan at the base of T1. So this basal area, and there's that fan there, it kind of blends in with this lateral edge of tomentome. And and then does it also, it should say in the key, yeah. Okay, it's not 100% reliable, so I guess I didn't use it in the key, but T1 is also going to be very, very shiny in Persinogaster. So you can see how shiny T1 is here. Setae has a very dull T1, usually. So, like I said, there might be some hybridization going on, so it's not 100% reliable, but usually Setae has a very dull T1. So here is Setae again. So here's the T1. And yep, the apical part of T1 is still going to be pretty shiny, but the base where the fan is, that's going to be very dull. So you can see that this basal area here is much less shiny than the apical area. I can get that.
So that
lighting on that. Yeah, so you
When
can see that microsculpture in this basal
Yeah.
area.
tricky to see, but that's where lighting comes in, where you want lighting that's askance rather than just straight down to see that microsculpture better. And sometimes it's really subtle.
There's also a good fan character for recognizing species in this group. So you can't really see it here because it's too dark and I don't know how to get the lighting in there. But Setae is going to have very, very short, sparse CD making up that fan. And in other species like the Perdiphycile group, which can look similar, those are going to have much longer CD making up that fan, much longer CD that kind of overlap each other. And then actually from this view, you can also see this lateral edge of T1, and there's no tomentum there, or very little tomentum, and it doesn't blend in with the acarinarial fan. There's maybe a little bit at the far edge here, but much sparser than it is in Persinogaster. And then if I see if I can show those other Droege. Yeah, so here is the
Reshare.
oh, am I not sharing anymore?
I showed a picture of the fan.
Oh, okay. Yep, there is a nice figure of it in the paper. So yeah, you can always reference the figures. All right, this might be the last share. So here's the metazoma of Setae. And if you remember, Persinogaster is kind of long and shaggy. Setae is much shorter and sparser. It's less shaggy, and there's a lot less of that plumose tomentum. So you can see like these hairs, they're shorter and they generally don't overlap so much. And it's also a little bit yellower. That's not really reliable, but in this specimen anyway. And then there's just less hair and it's shorter. And there again, you can see that lateral edge of T1, and there's a little bit of tomentum there, but it's really sparse, does not meet the fan. So that is Setae and Persinogaster. Pretty common species in the mountains. So watch out for those.
All right, so I think we're on to a different group for next week. If you're available, Joel.
Yeah.
We'll plow through. This is good. I think a lot of people, they're struggling here with Dialictus, and it's good to have clear explanations with pictures and something that they can go back to and get refreshed when they look at the videos.
Yep. So those were
Thanks.
all the species with dense punctures on the scutum. So in addition to the ones we looked at today, there's also the pilosum group, which we covered in a previous class. So with those, that's all the densely punctate ones. So next week, we're going to go back to couplet 13 and do some of the species where the scutum is sparsely punctate in the middle.
Question. Are there anything in this group that would have been in the Eastern guide that are in the Canadian guide?
Yes, I think there are. Let me quick check.
Would that be like Baccia and
Yeah, Baccia and
Ralliense, and what about Tamiamensis? Is that too sparse? I can't remember. These are deep south.
Yeah, those are species I don't see very often, so I'm not certain about those.
Yeah. I mean, we have them, but again, I think it's better to just to stick with the Canadian guide for now, and we can circle back to southern things. And when you get, you really want to go south, then you get into Texas and places like that, and it's crazy.
Oh, yeah. Baccia, Ralliense, Criberimum, and Tamiamense, and Miniatulum as well. Those are all southeastern species with dense punctures that will come out with that dense group.
Mm-hmm.
Yeah, that's worth noting. So if you're in the east, like East Coast, Southeast, Texas, there's more species with dense scutum punctures to watch out for.
Yep. They really don't get far north. They'll go up to coastal New Jersey. You can get Criberimum. I don't think it goes any further. And we get Criberimum. We have one record of Ralliense from Maryland. The rest you're really talking about Carolinas south.
Yeah, and they some of them can go east, or they can go west to Texas as well.
Yep.
I've seen some Ralliense from Texas.
Yeah. All right, Joel. Oh, go ahead, Claire.
I had a note from last time that you, Sam, wanted a special section on apical fin braid. But I think that was a Jason wording question.
Yeah, we can revisit that certainly another time.
Putting it in the mind brain bank.
Okay. All right. Thanks, Claire. Thanks, Joel.
Thank you, Jim.
We'll talk to you later. Happy Valentine's Day.
Happy Valentine's Day.
Yep. Bee mine, go look at mining bees.
Woohoo. Hey, Joel, you're gonna be writing cards because you won't make any money doing bees, but think about another profession.
Yep.